It is you! You have disgraced my father! You will die today!
It is you who will be doing the dying today.
Prepare to be uniformly accelerated!
What is uniform acceleration? What is uniform acceleration? That is a good question. While some of you might think uniform acceleration is an acceleration wearing a uniform, like a baseball uniform or like a basketball uniform, that's not this type of uniform. When we say uniform, we mean constant, as in unchanging. And that is exactly what this acceleration is doing. When something has a uniform acceleration, that means its velocity is increasing at a constant rate, so the velocity is going up without changing, which is pretty cool because we like things that are constant in our lives. It's pretty important to us. So like if I'm moving like this, my hand like relatively has like a uniform acceleration, but if I'm going like like that, like moving around at different speeds, then it really doesn't. So that's all you really need to know. Alright, so Jack is rolling down this hill. Let's say this is the hill. This is Jack. He's dead. Okay, this is Jack rolling down the hill. Ooh, that's the rolling motion. Okay. And there we go. Let's say it's 30 degrees, and that's 60 degrees, and that's right angle. Alright, we got those angles of the hill, so we can tell how he's rolling. We got gravity, the FG, which is a 9.8, and we got Jack, who is like 55 kilograms. That's his weight. Nope, that's his mass, and we multiply it by the gravity to get his weight. Okay. So we have these variables, and it's like, well, we want to find out uniform acceleration. How do we do that? So Jack's velocity is constantly increasing. That's fun. It's increasing at a constant rate. So to do that, we can solve for his acceleration, which just so happens to be uniform. So to find his acceleration, we know force equals mass times acceleration. Pretty crazy. So it's like, well, how do we find acceleration? Well, that's force divided by mass. Wow, how do we find the force given that? Well, our net force is going to be all the forces acting on Jack. So that's his F parallel minus his F friction. So, his net force is going to equal him times gravity times the sine of the angle of the hill, which is right here, 30 degrees, pretty amazing, minus him times gravity times the cosine of this same angle. Oh my god, the angle is back. That's 30. This is going so sideways. Oh well. And the coefficient of friction, which for grass is, thanks to Yahoo Answers, 0.35. So, once we calculate all of that, we get his net force is 106.124 newtons. And I did that all in my head because I'm really smart, and that's an N, I swear. Okay, newtons. Now, we have his F, and what? His mass. What? Oh my gosh, we have his mass too! So we divide that by 55, and we get his acceleration is 1.93 meters per second squared. Oh my gosh, that's his acceleration. Now, let me erase all that, and I'll show you how that looks on a graph. Now we're going to have a velocity graph. Alright, we got the meters per second and the seconds. So, we want an increasing, that's up, constant rate of change. So that's going to be like this. Look at how sort of straight that line is. Oh, continues on forever. Oh, pretty crazy. So, we have this graph. So now we want to know what uniform acceleration is like based on our velocity graph. So our acceleration is going to be meters per second squared, seconds, and that's going to be the slope of this graph, which is just a constant. What? That's kind of a straight line, which just kind of matches that, which is also kind of a straight line. So there we go. We have our uniform acceleration graph. And as you can see, because this is an mx plus b graph, if we take the derivative of the velocity graph, we get the acceleration graph. So you get rid of the x, and it's, oh my god, constant. It's a constant acceleration. It's uniform acceleration. Words. Oh my god. So yeah, that about explains it. I'm done.
So I'm just gonna be like, yeah.
One hand.
Oh wait, one
Both
hand.
of them? Really? I hit one hand and you like...
Oh, you wanted me to draw a graph? I thought you said giraffe. Okay, now we're gonna have a Nope, that's not how you spell it. Now we're gonna have. It was a simple mistake, okay? I was thinking of velociraptor. Okay,